So what we are going to do here, remember, this is what we are going to do. We're just gonna try to write this aside. So we're gonna start by taking this part, and then we're gonna write it aside, because that's the one that we are working with. So that is 2, the sine of theta, and then plus 1 is equals to 0. And then I'm gonna write 2 sine theta, and then I'm gonna take positive 1, transpose it that side. When I transpose it, it changes the sign to become negative 1. And then I'm gonna divide both sides by 2, because math says what you do on the left hand side to also do it on the right hand side. And then 2 will cancel 2 here, and then what are you left with? You are just left with sine theta, it's equals to negative 1 over 2. And then after this, you know that you are having one 𝗧𝗿𝗃𝗀. So you're just gonna write 𝗧𝗿𝗃𝗀, and then you're gonna check what is the ratio for sine. So we know that sine is equals to opposite of a hypotenuse. So since sine is equals to opposite of hypotenuse, this will be opposite over hypotenuse, right? So each and every time you must have 3 ratios, which is opposite side, which is y, hypotenuse side, which is r, as well as the adjacent side, which is x. So since we don't have the value of x, we're gonna get the value of x by using the theorem of Pythagoras. So the theorem of Pythagoras, it says the hypotenuse side squared, it's equals to the sum of the squares on the other 2 sides, which is x squared plus y squared. And then when you arrive here, it's a matter of you now substituting. So the value of r, as you can see here, the value of r, we are given what? We are given 2. So that will be 2 squared, it's equals to, let me do like this. So it's 2 squared, it's equals to, and then the value of x, we are looking for x, so that will be x squared plus, then the value of y, it will be negative 1. You say minus 1 squared. And then if it's negative, you must make sure that you put it inside the bracket so that it doesn't affect you. Ne? And then 2 squared, it will give us 4, it's equals to, that's x squared, and then plus negative 1 all squared, I think it gives you 1. And then this will be 4, and then you take positive 1, we transpose it to the other side, it's minus 1, it's equals to x squared. So 4 minus 1, that should be 3, it's equals to x squared. So you can write it as x squared is equals to 3, and then you introduce square root both sides. Now when you introduce square root both sides here, you must just write plus minus, because you don't know that your answer is positive or negative. Then this cancels that, so we are left with x is equals to plus minus root 3. So we are not sure when you are saying x equals to plus minus, our answer is positive or negative. What is going to basically tell us, it's our what? It's our restriction. So with that being said, you know that here you must draw a Cartesian plane, or your Cos diagram. So you're gonna draw your Cartesian plane just like that. So that will be 0 or 360 degrees, then that will be 90 degrees, that will be 180 degrees, that will be 270 degrees, just like that. And then on this restriction here, they're telling you to say what? They're telling you that theta must be less than 270. So this is 270, less than, you go clockwise, because anything less than 270, it's an angle that gets reduced, right? Or theta is greater than 90. Greater than 90, you go anti-clockwise. So with that being said, it means that my diagram can be either lie on the what? Can either lie on the second quadrant here. Can lie on the second quadrant. Or my diagram will lie on the third quadrant. Now what is going to make me to basically get the correct answer to say my diagram lies on the second quadrant or on the third quadrant? It's now me using the values that we are having, right? So let's use the values that we are actually having. So here you can see that the value of y is what? The value of y is -1. So -1 automatically, you know that is gonna be here. And based on me interpreting the restriction, I told you to say the diagram or the sketch will be second quadrant or the third quadrant. But to start with, don't look at the value of r, because r, it doesn't gonna help us. R is the hypotenuse side, that is the longest side on the triangle. R, it can never be negative. R is always positive. That's why I'm saying for that one, leave it now. So the value of y here, we got -1. So -1, when you look at it, it's somewhere there where I made a red dot here, this one, right? Then it means to say automatically your x value must be here, and you going this direction, you know that on this x-axis all the x values, they are what? All the x values here, they are what? They are negative. Hence here I'm now gonna conclude and say what? I'm now gonna conclude and say, okay, therefore what's going to happen? The value of x, let me write it here. I'm gonna conclude and say what? And therefore the value of x is equals to what? -√3. Do you see why I'm taking -√3? It's because at first I told you to say the value of y here is negative on the y-axis, so negative is gonna be somewhere here. And based on us now interpreting our cast diagram, we know that based on this is a restriction. And I told you to say on the previous lesson that the restriction can be given in two forms. It can be given in an interval form, it can be given in an inequality form. Now this one that you are seeing here, it's a restriction that is given in an inequality form. So as a grade 10 learner, you must know how to interpret the restriction using an interval form as well as an inequality form. That's why on the examples that I did, that I even sent on the group, I showed you how do we do the very same concept using an interval form as well as using an inequality form, so that you don't get confused, because in an exam they will bring either one of those. Now since you understand that, okay, the value of y should be negative, y is negative here, and then you are forced, because your diagram is gonna be either here or it's gonna be either there. Now since you now have the y value, it means to say your x value automatically is gonna be here. And when you are going that direction, the x value is gonna be positive. But since we knew that our diagram was gonna be here or there, automatically what's going to happen? We know that the value of x is gonna be negative, because the diagram will now appear on the third quadrant. That's why here the value of x, I'm taking a negative ant. Do you get to see that? And then after that, that's when now you draw your what? You draw your diagram accurately, so to say, okay, since now you understand that the diagram will appear on the what? The diagram will appear on the third quadrant. It means that now you draw it just like that. Now you draw it just like that. So this question is it's a typical exam question, and even in grade 11 students, they get this. Even in grade 12 we are still gonna get this. The thing is, students, they fail things which they were not supposed to fail. So x here, it's -√3. The very same concept that I'm teaching you. You see this question, as it is, you'll get it in grade 11. You'll get it in grade 12 just like this. The only difference is that here they will give you a question that has formulas for grade 11. Here they will give you questions that has to do with grade 12. But the very same concept, even on how you draw the Cartesian plane, it doesn't change. And one thing that is very important here, look at our angle. Now with regards to our angle here, we are given angle what? Angle theta. It means to say you go to the diagram here, you must write angle theta, and then you show the value of x, which is -√3. We are also showing the value of y. Our y, we know that is also what? It's -1. You should also show the value of r, which represents the hypotenuse side, which must always be positive, which is 2. Now after that, that's when now you can start to solve what? To solve the questions which they basically want. So do you see, I didn't even start I haven't yet started even simplifying. This is when I'm now gonna do this question. Now number 1, they want us to find 4 cos squared theta. I'm not sure if it's gonna be wise for me to write it here. Okay, let's try to write it. Do you all understand? I hope I'm not confusing you if I'm gonna write it here. So they want us to find 4 cos squared theta. I'm just gonna try to write it here. Let's try to write it here. And then or I think it's wise, let me just write it on the other side so that you don't get confused. So number one, they want us to find 4 cos squared theta. So this is what you're gonna do. Number one, they want you to find 4 cos squared theta. Now this is 4, you write 4, ne? And then you're gonna say open bracket. Now this is what you're going to do. This squared, before you proceed, you write it there, that is a squared. And then you're gonna check what is cos using 𝗧𝗿𝗃𝗀, right? Let's check that. So cos, it's adjacent over hypotenuse. Now since it's adjacent over hypotenuse, it's gonna be adjacent over hypotenuse. Now one person can write it like that, right? And then this is gonna be what? This is gonna be 4 into, now you substitute the value of x. Remember x we got negative root 3, right? Negative root 3 all over r is always positive, which we are having it on the diagram being 2. You're gonna write 2, and then we are having squared. They said without the use of a calculator, so they don't expect you to use what? They don't expect you to use a calculator. Now what you can do basically from this it can be written like this. Let me show you. Now it needs you to be good with regards to exponent. So this is the same as you writing minus root 3 all squared all over 2 all squared. This is one in the same thing. And get this squared here, it tells me what I'm gonna square the numerator, I'm gonna square the denominator. That's what I did. Do you see? That's why they said don't use a calculator. So this will be 4 into, now this one, let's do it aside. I wanna teach you something. This one, let's do it aside on a scribbler with a pencil. Ne? We are having what? We are having a negative root 3 all squared. So one thing that you need to understand is that this negative root 3 all squared is the same as me writing negative root 3 multiplied by negative root 3. Ne? And then negative times negative, we know that is positive. Then you'll be left with root 3 times root 3. So root 3 times root 3 is one of the same thing with you saying root 3 all squared. And then 2 cancels square root. You're gonna get 3. So in the entire thing here, this one, it gives us what? It gives us 3. So on the numerator side here, I'm gonna write 3 because that's what I got. I'm now showing you. I was not supposed to show you this, but I'm just showing you because I don't like using a calculator. So you're gonna write 3 over 2 squared is 4. 4, you all know 2 squared is 4. Do you see? Look at this again. This is maths. 4 cancels 4. Your final answer is 3. Your final answer must be 3. You are done. They said without the use of a calculator. This is how you show it. But if maybe you are not confident enough, even if they said without the use of a calculator, you can punch this on the calculator. Punch the entire thing on the calculator. Trust me, it will give you 3 just like that. So I wanted to show you this so that you don't panic, because if they say without the use of a calculator, they just want to see that are you smart. So number 2, we are done with number 1. Number 2, they said find 81 tan squared theta. So this is number 2. They want us to find 81 the tan of squared theta. Same thing. What are you gonna do? You're gonna apply whatever I was explaining. So do you all understand? Do you all understand? Okay. I even okay, sure. We welcome you also, Kaisone. So after this, you just gonna say they're saying 81 tan squared, right? Do this. If they're saying 81 tan squared theta, you write 81 first, ne? And then you write brackets. I'm explaining this again. That squared here that you are seeing is the one that you're gonna write aside here. And get here, if you remember, I said this squared, you write it there. That's why I'm writing it with a different color so that you don't forget. Start by writing 81. After that, you write brackets, and then this squared you write it there on the exponent. And then now what is going to do? You're gonna check what is tan theta using 𝗧𝗿𝗃𝗀. Now tan 𝗧𝗿𝗃𝗀 is opposite of adjacent, so it's gonna be opposite over adjacent. Do you see? It's very easy when it's like this. And then after this, you're just gonna say 81 into, you look at the diagram, what is the value for y? The value for y, as you can see here, it's -1. You're gonna substitute -1. So it will be -1 over the value of x. We got -√3. Actually, x is -√3, or you can take this one. It's -√3. So here you're just gonna write -√3. They said without the use of a calculator. They want to sound smart. You say squared. You use the laws of exponents, guys. You can't fail this. Let me show you something. Laws of exponents. This law of exponents, I'm gonna teach you another day, but in grade 8 and grade 9 they taught us this. A over b all squared. Guys, you can't fail this. This can be written as what? As a squared divided by what? By b squared. Very easy stuff. Look at this. This is a rule, guys. It's a rule. You can't fail this. As long as you understand exponents, then this is very easy. Look at this. To start with, before you can even go further, don't confuse yourself. You know that negative, it cancels negative. Start there. Do it step by step. And then you'll be left with h1 into, then now you are left with 1 over √3. I'm doing this so that you don't do mistakes. Squared. Now after this, that's when now you apply what? Your laws of exponents. This can be written as what? This can be written as h1 open bracket, and then, or rather, let me not say open bracket, let me rather say brace, and then that will be 1 squared. Do you see? All divided by √3 squared. Very easy. And then after that, what are you gonna do? I'm just gonna try to write it here aside. I like calculating a lot. So this is 81. We write 81, and then 1 squared here is 1, guys. So that will be what? Into 1, all divided by. Look at this. Now here, don't get confused. Here you simply gonna say 2 cancels square root. Why are we cancelling 2 cancelling square root? Because square root is approximately half. So it can be written, this one, it can be written here. It can be written as 3 to the exponent of half times 2. Those 2's, they're gonna cancel out. You're left with 3 to the exponent of 1. That is 3. But in simple terms, when it's like this, just say square root cancels 2, you are left with 3. On the denominator side, that 3 that I'm left with is the one that I'm gonna write here. I'm gonna say divide by 3. Now we are dealing with exponents. Straightforward. You say divide by 1. Why 1? So math says when you have a multiplication sign, brackets, you know that they represent the multiplication sign. What do? You multiply a numerator and a numerator. You multiply a denominator and the denominator. I didn't use a calculator. 81 times 1 is gonna be 81. All over. 1 times 3 is gonna be 3. It means that if you punch the whole of this entire question, even though they said they don't want to use a calculator, if you punch this on the calculator, the whole of this, it must give you 81 over 3. If you punch the whole of this blue part here on the calculator, it must give you 3. So I'm just saying, for the sake of those ones who might say, it's difficult to explain this, to do these things, that's when you can use a calculator. But the catchiest part is that if they can see, here I wrote 81 over 3. If they can see you writing an answer in decimal form, then they know that you have used the calculator. Then they're gonna penalize you. Then you will forfeit marks. So that's how basically we deal with this question. We are done. When others are stressing with this kind of questions, you get a distinction. This is very easy. The way I'm teaching you in grade 10 is the way I'm gonna teach in grade 11. Is the way I'm gonna teach in grade 12. So the thing is, it's you now understanding how basically you use the concept. There's no way you can deal with this type of questions without you doing what? Without drawing a diagram. That's why here they had to explain to say with the aid of a diagram. Because if you are drawing it without the aid of a diagram, then it's gonna be disaster. It's gonna be disaster. Any question? Okay, cool. Sure, that was goodness. Kaiso, do you understand? Okay, cool. Ndabentle, do you understand?
Yes, I understand.
Okay, cool. Then this type of questions, I can say we are now confident to say we know how to solve these questions. Now we are proceeding with another segment of what? another segment of trigonometry. So here comes another question. These ones. Calculate the following without the use of a calculator. That's, you can say, it's example number 2. So we can say calculate the following without the use of a calculator. Calculate the following without the use of a calculator. So for us to calculate the following without the use of a calculator, you're gonna use always special angles. Now on number 1, they're giving us what? They want us to calculate what? They want us to calculate sine 30, the sine of 30 degrees, plus what? Plus cos 60. Cos 60 degrees. Then on number 2, they want us to calculate tan 60 degrees minus cos 30. And then on number 3, they want us to calculate sine 60 all divided by what? Sine 60 degrees all divided by tan 30 degrees. Tan 30 degrees. On number 4, they want us to calculate cos squared 45. Very easy questions. You get a distinction. So what you're going to do with regards to these questions, this is what you're going to do. Always, guys, you use the very same concept that I'm using. So this is how we're gonna basically deal with these questions. Now the tricky part here is that you must always draw what? You must have special angles. You must have your special angles. So you must have your special angles. You must have your special angles. So you're gonna draw your special angles. Special angles. So the key point is that each and every time they say what? Calculate the following without the use of a calculator, the only thing that you can basically do in that regard is you now using special angles. Ne? So that's the only way in which you can do that. So these are the special angles that you must know. You must know these special angles by heart. You must know them by heart. They are not gonna appear on the formula sheet. You must know them by heart. So these special angles is what? Is 2, 30, 60, 1, square root of 3, square root of 2, 45, and then 45, 1, 1. Here we are having 90 degrees. Here we are having 90 degrees. Here, this small box, it's 90 degrees even here. So each and every time they say calculate the following without the use of a calculator, you must use special angles. And then after you now understand that you must use special angles, you must use it in correlation with what? With SOHCAHTOA. Ne? Then now we're gonna solve number 1, the 1 sine 30 plus cos 60. So that will be sine 30, number 1, sine 30 degrees plus cos 60 degrees. So what you're going to do, we're gonna say sine 30, and then if I'm using 30, I'm gonna go on a special angle for 30, and then I apply sine. So this is 30. Sine, remember, is opposite of hypotenuse. If I'm using 30, that will be your opposite of hypotenuse. Opposite of hypotenuse. So sine 30 is what? It's 1/2. So here you're gonna simply use 1/2. I'm not using a calculator. They said without using a calculator. And get, so it's gonna be 1/2. And then you're gonna say plus, what is cos 60? You're gonna go to the special angle for 60 degrees. Now the tricky part is that if you're using 60 degrees, always, guys, the side that is facing the angle that you are using is always considered the opposite side. If I'm using 60, root 3 is my opposite side, and then 1 is gonna automatically become my adjacent side. Now don't stress with regards to the hypotenuse side. It's always the longest side on the triangle. Even here, this one is the hypotenuse side. But the tricky part is that the angle that I'm using, if that angle is facing the side, that particular side that is facing the angle that we are using, is always gonna be the opposite side. Ne? So teachers, they normally say the adjacent side is always the one that is underneath. No, That's not how it should be interpreted. So here cos 60, I'm using 60. 60 is facing my root 3. Root 3 is my opposite side. Now what is cos? Cos is adjacent of hypotenuse. So this is going to be adjacent of a hypotenuse, which is going to be 1 over 2. Over. So here I'm going to also have 1 over 2. This one, the final answer is 1. But let me show you. Because we are having the denominator that is the same, you're going to write 2. And then you're going to write 1 plus 1. This will be on the numerator side. 1 plus 1 is 2 over 2, which is the same as 1. That's how you deal with it. We are done. We go to the second one. On number 2, the one tan 60 minus cos 30. So you'll say tan of 60 degrees minus the cos of 30 degrees. Now what is tan? So katoa, tan is, and you are using 60 degrees. Tan is opposite of adjacent. So using 60 degrees, that will be opposite over adjacent, which is root 3 over 1. So that is root 3 over 1 minus, and then cos 30, you check 30 degrees, there you go. Cos it's adjacent over hypotenuse. So cos 30 it will be root 3 over 2. So it will be root 3 all over 2. Now they said without the use of a calculator, when you're looking at this, this is root 3 over 1. Do you see? Minus what? Minus root 3 all over 2. Now I'm just trying to, I need to explain it using what? Using the easier method, so that you don't get confused. So what we can basically do there, we can do what? We can use the method of having an LCD, lowest common denominator, right? But your LCD is 2. So in easy terms, what you can do here, whenever you have a positive sign or a negative sign in the middle, you cross multiply. So it will be root 3 times 2, that will be 2 root 3. And then you're having a negative sign, you write minus. And then 1 times root 3 is 1 root 3, or one can say root 3 is 1 in the same thing. Because even if you were to say, okay, let's say 1 times root 3 is root 3. So let's write it as root 3. Then all divide by, I want to show you something. 1 times 2, you multiply the denominator, which will be 2. Now here, coming back here, you said 1 times root 3, that is root 3. But here, even if they didn't write anything, here we know that there is a coefficient, there's what? There is 1. And there is 1 there, which is the coefficient. And then look at this. Now I want to show you something, because if it's like this, maybe some of you might get confused like this. I want to show you something. I want to show you something. So what if I had 2x minus 1x? What was going to be the answer? If I had 2x minus 1x, what was going to be the answer?
X.
It was going to be x or 1x. Yes, x or 1x. Sharp. Since now we understand that concept, okay, let me now erase this. When I'm having a 2 root 3 minus 1 root 3, what's the answer? It's the same as the one that I just did now as an example. Yeah, the x. If I'm having 2 square root of,
I think
it's gonna be what?
I think it's gonna be root 3.
Correct. Root 3 or 1 root 3. That's why I had to do an example with the one that I erased. And then all divide by 2. The final answer is root 3 over 2. So don't get confused. Guys, when you're doing maths, just try to think outside the box. This is only the same thing with you having 2x minus 1x. So if 2x minus 1x, it's x. and then they're saying 2 root 3 minus 1 root 3. It must be root 3. Do you see? So the final answer is that. Get a distinction, you get a distinction. We are done with number 2. Easy stuff. So get a distinction, you get a distinction. Now we are dealing with number 3. Before number 3, goodness, do you understand? Kaiso, do you understand? Then Daventle, do you understand? Okay, sure. So on number 3, they want us to find sine 30 over tan 30. Sine 30 over tan 30. So we're just gonna say sine 30 root 3. This is sine 30 all over. Let me just check. That is tan 30. So on number 3, it's sine 30 over what? Over tan 30. So here I'm just gonna write tan 30. Now this one I wanna warn you first. Ne? I wanna show you something. This is sine 30. You start by writing sine of 30. Ne? This one is divide by. It's only the same thing with me writing divide by like this. And then what are you having? You're also having tan 30. It's only the same thing. You write tan 30. Look at this. Sine 30, sine 30. Divide by, tan 30, tan 30. You write it like that. So the reason why I'm writing like this is that maths doesn't allow me to have many division signs. Ne? So when it's like this, we're gonna check what is sine 30. You go to your special angles. Sine 30, sine, so opposite of hypotenuse, that will be 1 over 2 using special angles for 30. Sine 30 is 1 over 2. So you're gonna write 1 over 2 here. So it will be 1 over 2. You say divide by, you check what is tan 30. So you're gonna use the special angle for 30. And then tan is what? Opposite over adjacent. Now let me show you something here. Ne? So it's gonna be opposite over adjacent, which is 1 over root 3. Don't panic. It's gonna be 1 over root 3. Now 1 over root 3 is the same as root 3 over 3. How did I get root 3 over 3? Some people, they punch the calculator, but they said without using a calculator. Ne? But when you must know that this is a topic called the rationalizing the denominator. So when we rationalize the denominator, we write that 1 over root 3 as it is, because maths doesn't allow us to have our denominator being in a square root form. So it means to say I'm gonna multiply by square root of 3 or divide by square root of 3. Because me doing this, it's kind of like me, I did not do anything, because square root of 3 divided by square root of 3, it gives me 1. And then 1 over root 3 times 1, it gives me 1 over root 3. Do you get to see that? So I'm forced to do that. That's why even if you were to punch 1 over square root of 3 on the calculator, just to double check, it will give you root 3 over 3. How did they get it? They got it like this. It means to say you multiply the numerator and the denominator by your denominator, like what I did, because root 3 over root 3 is the same as 1. It's kind of like me not doing anything. And then when you're having a multiplication sign, math says what? You multiply what? You multiply a numerator and the numerator. 1 times root 3 is gonna be root 3 all over. Root 3 times root 3 is the same as you now writing root 3 all squared. Root 3 all squared. So on the numerator side, you are having square root of 3 all divide by, look at this, 2 cancels, square root, you are left with 3. Do you see where the root 3 where this answer is coming from? Is this one. So now, being a student, you must know that, oh, this is not cram work. 1 over square root of 3 is the same as square root of 3 over 3. I've showed you, ne? Because they say tan 30. Tan 30 is opposite over adjacent. But I can't write 1 over root 3 because I want to simplify it further. 1 over root 3, I know, based on what I've explained now, that 1 over root 3, which is this one, is going to give us root 3 over 3. So we're going to write root 3 over 3 here. Root 3 all over 3. Now when you're having this, ne, you're going to write 1 over 2. Again, math says when you have a quotient sign or a division sign, we call it a quotient sign. Guess called. When you're having a division sign or a quotient sign, what do? You introduce a multiplication sign, then you do the reciprocal. What is the reciprocal? The reciprocal means the denominator now becomes the numerator. the numerator now becomes the denominator. You kind of like swap them. Already swapping. That will be 3 over root 3. And then when it's like this now, you are more than welcome to say, okay, there's no need of rationalizing the denominator here because you're having a multiplication sign. So I'm going to multiply 1 times 3. I'm going to multiply the numerators. 1 times 3 is 3. All over 2 times root 3 is 2 root 3. But other students, rather than writing it like 2 over root 3, they will write it like this: 2 root 3 multiplied by 2 root 3 over 2 root 3. It's one and the same thing. And then 3 times 2 root 3. So it's kind of like you saying 3 times 2, that will be 6. It will be 6 root 3 all over. Now 2 root 3 times 2 root 3 is the same as you writing 2 root 3 all squared. But the tricky part will be here now. Don't do a mistake. Let's do this aside. So we are having 2 square root of 3 all squared. That can be written as 2 square root of 3 multiplied by 2 square root of 3. Ne? And then you multiply 2 times 2, it will be 4. Ne? And then root 3 times root 3 is the same as 3. Do you see? Then here it will be 4 times 3, which is 12. So it means that when you punch this, hey, I love maths, yo. When you punch this on the calculator, it must give you 12. This is not guesswork. I'm not creaming. I'm showing you how to understand it. So it's over 12. Do you see? So some students, they're gonna write it like this. They're gonna be correct. It only depends on who's teaching them maths. So it will be 6 root 3 all over. The whole of this ambiguous denominator here, it gives us 12. Do you see? But when you know that, oh, can I relay 6 into 6 goes once, 6 into 12 goes 2 times. Do you see? Now, what are you having? You are having a 1 times root 3, that will be root 3 all over 2. Do you see? So it's either you write 3 over 2 root 3 or you write what? Root 3 over 2. But if you can write this, myself, I'm gonna not give you all the marks. If you can write this, because this is not simplified. So that's why I had to explain it aside to say, the answer is 3 over 2, just like that. So the one who's gonna write this, gonna get the mark. If this was out of 5 marks, or let me rather say 4, the one who write root 3 over 2, I'm gonna give him or her 4 marks. If you write this one, I'm gonna give you 3 marks. So that's the tricky part. We are done with number 3. You get a distinction. We are done with number 3. You get a distinction. These are easy stuff. Number 4, the one cos squared 45. Let's do this one, cos squared 45. Number 4, the one cos squared 45. Ne? So cos squared 45 is the same as you saying the cos of 45 and then you square it. And get it? So what is cos of 45? Let's check. You're going to use a special angle. Now, with regards to 45, it doesn't limit you. You can use this 45. You determine cos. Cos is adjacent over hypotenuse. That's going to be adjacent over hypotenuse, which is 1 over root 2. But I did explain to say 1 over root 2. 1 over root 2 is the same as root 2 over 2. Even if you use this one, it's going to be 1 over root 2, which is root 2 over 2. And get here, we got 1 over root 3. That is root 3 over 3. Same as applies. 1 over root 2 is root 2 over 2. So here you're gonna write root 2 all over 2. When it's like this, you use laws of exponents. You square it. You square the numerator, as in like square root of 2 all squared. All divided by 2 all squared. Right? Then look at this. 2 cancel square root, you are left with 2 over 2 squared, it's 4. The final answer is 1 over 2. How did I get 1 over 2? 2 into 2 goes once, 2 into 4 goes 2 times. Final answer is half. You get a distinction. You are done. Any question?
No question for now, sir.
Okay, sure. That was in the event, ne?
Yes, sir.
Okay, cool. Kaiso, do you understand? Okay. Yes, I'm recording the lesson. I've recorded the session. Okay. Goodness, do you understand?
Yes.
Okay. Yeah, I'm gonna slightly send the recorded of the session after we are done, so that you can just try to go through them. But some of the steps myself, there's no need of you writing them. It's just kind of like me showing you. I want all these steps here, like this one. Just save yourself. There's no need of you writing this. It's just me trying to show you how do you work with it. So just press this on the calculator. It will give you that √2/2 just like that. So that's how basically we solve such questions, guys. And then I think I've covered what I've wanted to show you today. And then okay, let me just try to share this. Maybe you don't have it. I'm just gonna try to share a textbook that you can use, because some of you maybe in class you don't have textbooks and things like that. So you can just use that textbook that I've just forwarded on the group if you want to. If you want more practices or more exercises, it's one of those textbooks that is very good. I've shared it there. I've shared it on the group. I've shared it on the group there. So you can utilize that textbook if you want, or any other textbook that you have. Then you are good to go. So those are some of the things that I wanted to basically explain. I've prepared that for today. So it just needs you now to do what? To go there and put more work. So when I'm saying put more work, it means that you do what? You practice. Ne? So it's just a matter of you now. Yeah, it's just a matter of you now practicing. Because so far we are good to go. I think we can conclude the session. So what I'm gonna do, because this is what I've prepared, so I'm just going through the textbooks, but most of the things I've just tried to explain it. So on the next session, what I'm gonna do, I think I'm gonna touch trigonometric graphs, because I want us to conclude with the topic of trigonometry, and then after trigonometry maybe we do graphs, as in like parabola, hyperbolic function, as in like exponential function, so that you can basically get to understand how do we deal with those. Or maybe we deal with another topic, but I think maybe it's gonna be wise for me to teach functions for paper 1. So on the next session for maths, I'm gonna do trigonometric graphs, or let me just try to see if time will allow. Or yeah, maybe plus minus we are left with plus minus 10 minutes. I think it's gonna be wise. Okay, let me just start there even now, so that we save time for the best. So here I'm just gonna try to explain, even if maybe I will explain one or all of them. It depends on time. Trigonometric functions. But with regards to this, we're having 3 types of trigonometric graphs. Number 1 is this one for y is equals to what? Y is equals to sine of x, or they can say y is equals to sine of theta. Now if they want you to draw the sine graph, this is what you are going to do. Ne? This is what you are going to do. This is what you're gonna do. You're gonna plot it like this, and in most instances they will say draw they will give you a restriction, ne? And then they can say for x is an element of brace, they can say 0 degrees to 360, because it depends on the restriction given. Now if this is 0 to 360, here I must start at 0 degrees. Now remember that this is my x-axis, remember that this is my y-axis right here, and here it will be the maximum value, which is 1. Here it will be the minimum value, which is -1. So that will be 0. Here we are having 90 degrees. Then here we are having 270 degrees. Sorry, after 90 it's 180. It's 180. 0, 90, 180. And then it's 0, 90, 180, 270. And then we're gonna have 360. So we know that, look at this. How did I get these numbers? We know that from 0 it's 90. When you add 90 plus 90 it's 180. 180 plus 90 is 270. 270 plus 90 is 360. Ne? So that's how basically it is. Now the sine graph, it started 0 and then it goes to 1. It's 90 and 1. Then it comes back to this one, and then 270 it goes hand in hand with -1. Then 360 it goes with 0. So for you to master this y is equals to sine x graph, just understand that the sine graph, if you draw it, it's like this. It's kind of like a wave. Now since it's a wave, this one here started 0 and 0. Then it will go to 90 and 1, which is this one here. It goes to 180 and 0. It goes to 270 and -1, and then 360 and 0. So this is y is equals to sine x. Ne? And then after that, now what you can do, you now join those. You now join those points, you now join them. Just like that. Never use a rule. If you can join these points using a ruler, then it's no longer a what? It's no longer a graph. It's now gonna be considered as absolute value. Absolute value, it's another topic in maths. It's not trigonometric graphs. And then after this, guys, what are you gonna do? You must make sure that you do what? You label your graph. As in, like, you're gonna do like this and say y is equals to sine of x. You are done plotting. Some students, they even go to an extent of now labeling the coordinates to say, okay, sir, we now understand that you have taught us how to draw the trigonometric graphs, and then here it's gonna be what? It's gonna be 0 and 0. Here is gonna be what? It's gonna be 90 degrees and 1. Here is gonna be what? It's gonna be 180 degrees and 0. Here is gonna be what? It's gonna be 270 degrees and -1. Here is gonna be what? It's gonna be 360 degrees and 0. That's another way in which you can draw this graph. Do you see? So I'm still having plus minus 5 minutes or 9 minutes. So the thing is, I didn't want to explain it, but I'm just finding myself explaining it so that you can learn a thing or two. Now this is how you draw the trigonometric function. Now one thing that they can basically ask you after drawing the trigonometric functions, they're gonna always ask you 5 questions. Ne? They're gonna always ask you 5 questions. So those 5 questions, number 1, they will say determine what? They will say determine the maximum value, or not even say make determine. They will just say what is the maximum value. So these are questions that you must know. Number 1, they will ask you about the maximum value. So the maximum value is this one. So this graph, let me show you something. This graph is maximum here. So this point here, that is always going to be your maximum value here. This is always going to be your maximum value. Maximum value. This graph here, this point here, is always going to be what? Your minimum value. Minimum value. So that's one thing that you need to understand. So after now you get all those coordinates, when they are saying what? When they are saying maximum value, your maximum value, when you check here, it's 1. 1 is the maximum value. So maximum value, will just say gonna be 1. Number 2, if they ask you about the minimum value, who can tell me what is gonna be the minimum value? Who can tell me what is gonna be the minimum value? So the minimum value is this one here. It's gonna be -1. So here you're just gonna write -1. Number 3, they will want you to find the amplitude. Now the amplitude is the distance from here. The amplitude is the distance, this distance here, this distance from here going there. So you can see it's what you can see that it's 1 unit, the distance there from here going there. It's an amplitude, right? So you're gonna write 1. The amplitude is gonna be equals to 1. But to those who don't know, you can find the amplitude using a formula always. So there is a formula that says amplitude, it's equals to what? It's always gonna be equals to the maximum value minus the minimum value, and then you always divide by 2. So this formula right here is the formula that will help you to determine what? It's a formula that will help you to determine what? To determine the amplitude, so that you don't guess. I didn't guess. This is the amplitude. I know that that is a distance, the amplitude. If you are doing physics, you know that the amplitude is the distance between the crest and the trough. That's why I'm saying that the answer here is gonna be 1. But remember, about Thomas Makolaga about Thomas, it means that amplitude you just gonna say use the formula maximum minus minimum, and then we divide by 2. So amplitude is gonna be, your maximum value is this one, which is 1. So you'll say 1. On the formula sheet here we're having negative, you say minus. What is the minimum value? Minimum value is -1. It means that you say open bracket minus 1 all over 2. So amplitude is going to be equals to, remember it's negative times negative is positive, so it will be 1 plus 1 all over 2, which is going to be equals to 1 plus 1 is 2, and get all over 2, which is equals to 1. Do you see where is this one coming from? I didn't guess. I knew that this is the distance. That gives me what? That gives me the amplitude. Or you can use it using the formula. So it depends on which way do you want to interpret that. But at the end of the day, it's the same thing, guys. Amplitude, and then after you are done with the amplitude, I think they will ask you about the what? They will ask you about the domain and the range. And then after the domain and the range, then you are done. Number 4. They will ask you about the domain. So when you speak about the domain, it's all possible values of x. So the domain, it will be x, an element of this graph is started 0, you're gonna write it where it ends, that is 360, right? So you'll say domain, it's x is an element of brace, the graph started 0, then it ends at 360. That's your domain. So domain is all possible values of x. Or it's kind of like you saying we're gonna draw the only part where the graph appears on the x-axis, just like that. Range is all the possible values for y, that is the range. Number 5, the range is all possible values of y, so it will be y is an element of brace. This graph is coming from -1 to 1. Do you see? So we'll say -1 to 1 brace. And the thing is, the difference between a small bracket and a big bracket, a brace, these ones we call the mama brace. A brace, you put it where you know where your graph started and where you know where the graph ends. If I know that my graph starts here, it ends here, I'm always gonna put braces. You're always gonna put a brace. If you know where your graph starts, if you know where your graph ends. If you don't know where your graph is starting, if you don't know where your graph is ending, you put small brackets. But in an exam, the instances whereby you put a brace, the instances whereby you also have another small bracket. So in simple interpretation, it means that this guy here knows where the graph starts, but he doesn't know where it ends. Sometimes they write it like this: small bracket and brace. This guy here, he doesn't know where the graph is started, but he knows where the graph ends. Now those are the things that basically you must know as a what? You must know as a grade 10 learn. So yeah, let's just end up here, guys. So thank you for joining, but this is just the basic. Ne? We are done with the sine graph. And under sine graph, they will tell you to say draw the graph of y is equals to sine x. But if they don't say y is equals to sine x, they can say draw the graph of y is equals to sine theta. It's one and the same thing. They can use theta, they can use x, they can use beta, which is like this, they can use alpha, they can use rho. It depends on what they want basically. But yeah, sine graph, you must know how to draw it. You must know the maximum value, you must know the minimum value, you must know the amplitude. I've showed you how to find the amplitude. You must know the range, you must know the domain. Domain, all possible values of x. Range, all possible values of y. Then we are done for today. Next session for maths, we're gonna be doing a trigonometric graphs and a tan graph. Any question? Any question? Any question? Any question? Any question? Goodness, any question?
None, sir.
Okay, sharp.
She's gone.
Eh? Eh? Okay. Oh, okay. So, but okay, today we'll just have to end up here, and then I'm gonna do what? I'm gonna send you this recorded session so that you can just sit down and try to go through it. But thanks guys for joining, ne? Sharp.